large, volunteer-driven open source project, and it means some very specific things. Python is about 400,000 lines of code. Coverity inspected all of the C code in Python. We'll talk about what I mean by C code in Python in a second. And from Coverity's perspective, Python has fewer than 0.01 defects per 1,000 lines of code. So I mean, just think about code you've written recently, code you've reviewed recently. See how that stacks up. Coverity does this for lots of projects, lots of proprietary software as well, and they publish statistics on how open source and proprietary projects do on average when run through the Coverity battering ram. And you'll see that proprietary software has on average 0.66 defects per 1,000 lines of code. Open source software is doing slightly better, but Python is doing an order of magnitude better. This is just a bunch of volunteers. And that is an amazing standard that the Python community strives for, and it's indicative of our philosophy around being a stable and mature language. This is really important for the enterprise. Okay, so the sort of development ecosystem around the Python core language seems pretty compatible with enterprise software. Python is in it to win it for the long term. But what can you actually use Python for? We talked about this a little bit earlier. I mean, is it mostly a scripting language? What do people actually use Python for in the real world? You might be surprised. There are a couple of sort of obvious examples. You may have heard that Reddit is written basically entirely in Python. You can, in fact, go on GitHub and check out the Reddit source code and tweak it and issue pull requests if you want. The vast majority of YouTube, and in fact, lots of projects at Google, are written in Python. And this is a big deal because these are sizable installations, right? These are installations dealing with serious traffic. They have serious performance considerations on a serious scale, and they're written basically entirely in Python. There are a lot of popular web frameworks. So in this space of sort of web development, there are a lot of popular web frameworks. A really popular one is called Django. And here are a couple of familiar faces. These are all sites that were written in the Django Python web framework. You might have heard that Python has become increasingly popular in the sciences. And this is particularly interesting because the sciences often deal with high-performance computing, big data, a lot of concerns that may be similar to certain enterprise platforms. And Python has been making really great headway in the sciences as well. Here are a couple of examples, a couple of sort of marquee users of Python in the sciences. There are a lot of, particularly in the area of science, Python has some really robust libraries. A really popular one is called Matplotlib. It's sort of the state-of-the-art and open source for data visualization in Python. It's really a shame that the bottom of these slides is cut off, but it's too late to turn back now. And right, the reason why Python is so popular in the sciences is because it has this suite of really killer libraries that have been optimized for various types of scientific computation. There are even Python distributions produced by companies that are specifically focused on making it very easy for scientists to get up and running and doing their work in Python. Language interoperability is a big thing for the scientists, but which also might be a big thing in other domains. You can run your Fortran code. You can call out to Fortran code or to C code from inside of Python. And we'll talk more about that in a bit. And that can be really important for scientists, but it may be important for you as well. This is one you might not have guessed. Does anyone play EVE Online? Has a friend, willing to admit your friend plays EVE Online? Maybe? Yeah, okay, exactly. EVE Online is entirely, the backend is like the server backend is entirely written in stackless Python, a variant of Python. So this is not Python being a glue language for a game. This is a massive multiplayer online role-playing game written entirely in Python. And you can write these giant, networked games in Python. You can also do sort of fun things. In the bottom left is an open source game called Frets on Fire, which is a clone of Guitar Hero and things like that, written entirely in Python. On the right, this is a Minecraft clone written in less than 1,000 lines of Python. That's pretty cool. There we go. Awesome. Thank you. I have that. Which one, left or right? Oh, great. So you probably merged a pull request of mine. Awesome. Great. He said he wrote the Minecraft thing we're looking at. Amazing. Yay, open source. But there's more. This is, okay. Well, you can't see the top and bottom, but this is a clip from Star Wars Episode 2. Very good, okay. So Industrial Light and Magic, dealing with a lot of serious graphic stuff for Star Wars Episode 2. A quote from one of the senior technical directors on that project. Python plays a key role in our production pipeline. Without it, a project the size of Star Wars Episode 2 would have been very difficult to pull off. From crowd rendering to batch processing to compositing, Python binds all of these things together. That's pretty high praise, and it doesn't get more. I mean, this is a big ordeal, and Python played a pivotal role in bringing this movie to us. And then another area where people are surprised to see it, so this is the New York Stock Exchange. Python is really popular in finance, for a lot of the same reasons why it's popular in the sciences. You can do the data analysis, the visualization, the high-performance computing, and Python powers the New York Stock Exchange's web-based transaction system. A couple of businesses. Rackspace. Rackspace has hired like every Python engineer I know, which is pretty incredible. Nokia, Dropbox's desktop client is entirely written in Python. And really, there are lots of examples in this space, but here are just a couple. So it should be clear that Python is not a scripting language. Python is not a glue language. You can absolutely do real, substantial, performant, big data-y work in Python. A recent addition to sort of the suite of domains where Python is really excelling is with interacting with hardware. Has anyone played with a Raspberry Pi recently? Yeah? A Raspberry Pi is a credit card-sized $25 Linux machine. And the Raspberry Pi Foundation decided that Python was going to be the default language, the default programming environment for the Raspberry Pi. So on the left, there was an NAO robot programmed in Python. On the right, someone's playing Pong on a Raspberry Pi written in Python. In general, for all of the reasons why Python is a pleasant language to develop in at the higher level, Python is a great language for hardware as well. It makes it very easy to, that interface is still very easy to work with. And even mobile. Now, I'm going to guess that nobody in this room has actually written a mobile app in Python. Anyone want to raise their hand and tell me I'm wrong? This is definitely a new and small ecosystem, but if you wanted to, you could write cross-platform, multi-touch apps in Python using a very popular new library called Kivy. So we're really running out of domains where Python does not seem to be able to play a role. Okay, so how does Python do this? This scripting language that should be slow, like how is it being used in all of these various domains in these incredibly performant ways? Well, this is interesting. So CPython, which is the sort of the default Python interpreter, the reference interpreter, the implementation of the Python bytecode interpreter, the vast majority of CPython is actually written in C. So when you run Python code, you're actually mostly running C. So you're actually much closer to the metal than it feels with the expressiveness of Python. And this is a big factor in the actual relative performance of Python. Python is really a pretty performant language if you do the benchmarks on it. So that's kind of cool. And if sort of the space is interesting to you, you might also be interested in a couple of other Python implementations. So CPython is the default, the reference in implementation. But if you are really wedded to sort of a Java stack, there's an implementation of Python called Jython, which runs in the JVM. IronPython is a Python implementation on the .NET stack. That's kind of cool. So Python really can exist in many ecosystems, not just the default one. So Python is in general fast enough. And when it's not fast enough, we have even more tricks to help ensure that you get the speed that you need. So a couple of flagship ideas in this space. One is another Python implementation called PyPy. PyPy is a version of Python with a just-in-time compiler. And what exactly that means would be its own talk, but if you can imagine, you're going through, you're executing code and there are some hotspots that happen repeatedly, PyPy will, on the fly, compile, do an optimizing compiling pass across this hot path to produce optimized machine code that can get executed directly. And if you look on the right, the blue bars is PyPy performing against the orange bar, horizontal bar, which is the CPython reference implementation. So on many, many benchmarks, in particular, sort of computational benchmarks, PyPy can be an incredible performance gain for you. So if you want to use Python and you find that for some computations it's still not fast enough, you may find that just running it on PyPy instead makes it, boom, all of a sudden wicked fast. Cora is an example of a big installation that uses PyPy. Another idea, harkening back to what I mentioned before about CPython being mostly written in C, Python has a foreign function interface. So what you can do for those hot paths that really are not performant enough in Python is you can write them in C. And you can call the functions implementing that hot path from inside of Python. So you get the flexibility and the high levelness and the joy of writing Python for the majority of your code, but for those little patches that really need to be closer to the metal, you can write a C extension for them. So that's pretty cool. And then sort of playing off of the second point, oftentimes what you really need is a highly optimized domain library that lots of kind people will have already written for you. So particularly in the sciences, there are some really good examples of libraries like SciPy and NumPy, which have a bunch of C extensions, have meticulously optimized data structure and algorithmic choices to make your performance and memory footprint what you need it to be in your domain. So these are sort of 3 tricks that you use inside of the broader Python ecosystem to make your code as fast as it needs to be. And this really covers the vast majority of cases. So when people say that Python is too slow, mostly say that they're wrong. So that was Python the language and the development and the use in the various domains. But a really important feature of a language is its community. So let's talk about that for a second. What is the Python community trajectory looking like? Well, Python is undeniably popular. Here are some statistics from GitHub. You have sort of lines of code on the left, and then the relative popularity of some of the languages on the right. Python is definitely in the top 5. So in addition to the Python core language and standard libraries, there are over 35,000 packages on the Python project index, giving you additional libraries, additional functionality on top of the Python language. How popularity is measured is kind of a subjective thing. Here's another way of doing it. This is PyPL, the popularity of language index. And what this does is it accumulates data about Google keyword searches. And it considers itself a leading indicator because it's looking at data about people learning a language, people going through Python tutorials, things like searching for keywords related to learning a language. So in that respect, it's a leading indicator because it's a sign of people starting to invest in the language. And we see here that Python is going strong. It's actually the only language that's going strong in the top 9 that we can see here. This is for September of this year. So in terms of people sort of the rate of people investing in learning Python, we continue to go up. It's encouraging. And we can look at historical data for this, just to give you a bit of annotation. So Python is the pink one. This is from 2004 to 2013. And let's just to highlight a couple of other languages here. And this graph is really pretty interesting. Some languages undeniably have staying power. Like Java at the top, props to the Java community. It continues to do well. That's great. There are a couple of sort of worrying trends here. I would say that Perl is maybe something to look at as to why its trajectory is the way it is. As a language community, as someone who invests a lot of time in a language community, I would want to figure out how to avoid Python having that trajectory. But Python is looking pretty good. We saw the sort of the short-term growth in this chart, but even the sort of the longer-term trajectory is looking pretty great for Python. Another way we can look at this is what are universities choosing to teach in? And universities are funny because they are like the last people to adopt anything, right? So if a university is adopting a language, it's probably here to stay. Unfortunately, some people do studies on this stuff. People have been keeping track of this thing called the read list for many, many years. And they have sort of meticulously surveyed and accumulated data on what various universities in the US are using to teach programming. And the first two languages, the top two, are probably what you'd expect. They're Java and C++. But Python makes a strong showing in third place. And again, if we looked at the trajectory for Python, it would be pretty meteoric as well. They interview professors as part of these surveys, and a lot of professors said, well, either they said, heck yeah, we're switching to Python, or they said, we haven't switched yet, but we're definitely thinking about it. Right, so universities believe in the staying power of Python and its value as a teaching language and its value as a language that its students graduate with into the job market. So that's pretty important as well. And this totally matters. I mean, this stuff matters for me as a developer because I want to invest in languages that I can get hired to use, and preferably languages that I enjoy using, that I can get hired to use. And for enterprise companies, it's a bummer to build a software stack that you can't hire people for because nobody knows the languages. You know, outside of some very niche cases, all things being equal, if you have lots of great developers to choose from, that is better for you. And hiring is already hard enough as it is. And even just taking a quick look at online learners. So has anyone taken a class from Coursera or edX or Udacity? Some folks. So these are these massive online learning initiatives. It is not an accident that all three of these platforms use Python as their introductory programming language. So they have attracted 300,000 learners to their platforms using Python. Pretty interesting. Python is a global language. Python is certainly popular in the United States, but when I visit Europe, when I visit Asia, when I visit Australia, I can go to a local meetup group. And that's pretty important. It's important for developers to have a place where they can go and meet people who like the languages that they like and continue to learn and expand their skill sets. This is important for hiring. So there are over 200 communities on the sort of the official Python wiki as well as on this meetup page. There are tons of Python conferences all over the world. Have people been to a PyCon before? Nobody? Just, oh, okay, great. Well, that's good. So PyCon North America is happening in Montreal in April. I'll be there. I would totally encourage you all to come join me. Early bird tickets are on sale now. But this is good as well, right? This means that there is so robust an international community that people hold conferences in Budapest, in East Asia, in New Zealand. I mean, that's pretty amazing. And then one other interesting point here, because we talked about science earlier and about science, Python really making progress in the sciences. There's an initiative called Software Carpentry, whose whole shtick is, quote, making scientists more productive by teaching them basic software engineering skills. So this is stuff that you and I take for granted, mostly, hopefully. Stuff like version control, at least some basic programming so that you can do stuff like automate your experiments, automate your data analysis, automate your testing, interacting with databases, regular expressions, other really sort of good core software engineering skills like that. And software carpentry events are happening in universities all over the world. They've run hundreds. They have giant grants from various nonprofits because a lot of people believe that software carpentry is part of the future of open access. Like when you teach scientists these skills, they now have the tools to do reproducible data and to do it in an open way and to share that data. That's really important. And you might think, okay, well, scientists, is it like in Mathematica? Is it in MATLAB? Is it in R? No. In fact, the primary language that software carpentry teaches in is Python. It's another really interesting, strong sign for this language that even the scientists are getting on board. So we have a robust community, a robust global community. The killer feature that is driving this community development is the Python Software Foundation. The Python Software Foundation is a 501c3 nonprofit. It is the stewarding organization behind the language. It deals with IP protection stuff like enforcing trademarks. But because it's a nonprofit, it's also able to acquire and then reinvest money into the community. And this is a pretty unique position for an open source, volunteer-driven programming language. It's hard to think of others that have this set up. And this means that Python is continually reinvesting in itself. And that is part of, I believe, that is part of why Python has that incredibly positive trajectory in that programming popularity index. Because Python is constantly investing in itself and in the language. So here's some things that the Python Software Foundation does. If you remember that PyPy, just-in-time compiler Python implementation from earlier, they are supported in part by the Python Software Foundation. So you get these things that start out as highly experimental, long-term projects. PyPy has existed for over 10 years. It was not fast. It was not a fast just-in-time compiler for a long time, but it recently is. And when you have this institution that's able to invest money in the community and invest money in research, that means that without being beholden to sort of corporations driving development, this language can make academic progress and industry progress. So there's a grants program that allows you to do this. There's a sprints program. People hack on Python core itself, popular libraries, and we'll help pay for it, give you the free pizza, get everyone to come, attract new developers to the community. Because when it's a bunch of open source volunteers, sustaining the community of active developers is really important as well, right? So the PSF is helping support all of this. A really important part of what the Python Software Foundation is doing is outreach and education. And this is outreach and education on a lot of levels. This is hooking up kids with Raspberry Pis. This is sponsoring conferences in places where there haven't been conferences before. The first ever Python conference in South Africa, the first ever Python conference in various countries in Asia. And it also tackles getting more underrepresented groups into the community. There are a lot of organizations within sort of the Python community that are dealing with this. A really famous one is called PyLadies, which focuses specifically on getting more women into this open source ecosystem, but there are many others. And this is important for you and for me, because when a language focuses on this outreach, it focuses on how to be a better community for people of all backgrounds. It makes Python have to think about how to be a better place for beginners to learn and beginning developers to develop in an open source ecosystem. In terms of hiring people, it's a total bummer that the latest statistics that are available suggest that 2% of open source contributors are women. That means there are a bunch of women. And keep in mind, this is 2%, which is much lower than the industry average or the academic average. And I'm sitting here desperately trying to hire people, and sort of vast swaths of the potential population are somehow falling through the pipeline between school and open source. So it's great that the Python community is investing in outreach in these issues for itself, the ecosystem, but also for the broader open source ecosystem. So why is Python so popular? Why is Python a good choice for you and for me? Why is Python a good choice for our companies? Well, it's popular. It looks like it's going to be popular for a while. It is effective and performant and a pleasure to work in across a range of domains. And it is a language that is constantly investing in itself and in the community. Those are all pretty compelling reasons. And that's why I believe, and the data suggests, that Python is a great investment for us and for our companies in the enterprise. So that's my pitch to you. Thank you. Does anyone have any questions? Yes.
So I work in a company, it's a defense contractor. We use Matlab. We pay MathWorks a metric time per seat.
Total bummer.
Their software.
Yes.
But the attractive part to that is that we can go to the leadership or the IT people and we say, it doesn't work, call MathWorks and get it fixed. And so if I make a pitch to the leadership to say, let's move our processing and scientific computing to Python, the next question will be, well, are you going to support it?
Yeah, that's a great question. And the answer to this is sort of textured. So one answer to this is, Oh, I'm sorry, great. The question was, I work for a defense contractor. We pay a ton of money out the nose for a contract for proprietary software. Okay, so I want to switch to Python, but the first thing that my boss is going to ask is, well, what's the support contract like? So there are a couple answers to this. One is that you can, Python, the language, and the ecosystem is free and open source software, but you can pay for support contracts with various companies that specialize in Python support. Another answer to this question is, because Python is this open source project that is continually getting improved, and as we saw from the Coverity reports, is unusually high quality for software, you may find that you don't have as many issues. The fact that this stuff is all being done in the open, with many eyes, all bugs are shallow, right? So that's another answer. And then the third answer is, I think in many cases, you develop expertise in-house that make the trade-off between this thing that is free and incredibly efficient to develop in versus maybe some maintenance costs. It's still a valid trade-off. Cool. I saw a hand over here first. Is it? Yes.
So Python is really great to code in and enjoy it a lot. When you say for the enterprise, though, one thing where we've got a big problem is Python support for encryption and cryptography. So understand, if you're trying to do something for the enterprise or for the government, they're really worried about who wrote those libraries and have they been certified, and there's none of that. So we tried to do, we did some OAuth work for OpenStack. We had to barely found a library that would meet our needs underneath for the cryptography. So what can the foundation do? Because that's sort of one of the few holes that I see that's holding Python back from being able to really take off.
Yeah, that's fantastic. Just to reiterate, so some folks have an opportunity to use Python, but they find that there are sort of these particular enterprise cases that are not really being met by the Python ecosystem yet. An example of this is sort of the cryptography libraries and certification for those libraries. And what can the Python Software Foundation or the Python ecosystem do about that? Number one, we should talk after this. Number two, the fact that it's open source software means that we have an opportunity to work on this together. And that there are lots of people who are interested in contributing if they realize that this is a thing that needs to be done. So if we saw even in the, way back, Python is an actively developed language, and it had, even in this latest release, had some sort of crypto-related improvements. So these things absolutely happen. They happen, the forcing function is people in the community being willing to implement them. So I think that it sounds like your company and the PSF should talk, we should make something happen. And that's part of the beauty of open source is that you could have these conversations. It's not, behind closed doors. Cool. So just to reiterate that, so in particular for people doing scientific computing, there are specifically Python distributions that are produced and maintained by companies that you can buy support contracts with. And there was also a response to the sort of the crypto question. Python implements Python bindings for OpenSSL, and there's some amount of certification around the underlying library. So there's a question there about you may have enough rope to give yourself the certification that you need, but we'll see. Yeah. Other questions? Yes.
Python 3 is different language from 2.7 version.
That's a good question.
We program my own code. This is the only language that I know whose latest version is not compatible with the older version.
Yeah.
So, and what do you see future of 3 versus 2.0?
Yes, that's a great question. So if you've used Python before, you maybe even just heard that technically there are really two versions of Python that are incompatible. There's sort of the 2.x line, the older line, and there's a 3.x line. And the Python community made a very bold choice half a decade ago that there were defects in the language severe enough that there was not a backwards compatible way to address them, and that the correct way, or the way that they were going to try to address these issues, was to sort of fork the language slightly. It's still it walks and talks pretty much like the Python 2 that you might have used, but it fixes these sort of language defects. And Python is on a 10-year plan to transition itself and the broader ecosystem, because there are 35,000 Python libraries that would need to be migrated to this slightly different, newer API. So one statistic is that Python is on target for its 10-year plan. So the Python community tracks very carefully the adoption of Python 3 by important community members and by libraries. And as far as we can tell, this admittedly ambitious 10-year plan we seem to be on target for. So that's interesting. Now, in terms of this being sort of a pain in the butt for having Python 2 code that you have to migrate, Python 3 is 100% the future. Python 2 is only receiving sort of security and maintenance updates at this point, and will eventually stop receiving those as well. Python 3 is the only Python that will exist going forward eventually. And so transition is inevitable. I would say that Python will probably never do this again. There are not a lot of examples of a language choosing to make this kind of split. And I think that we'll be able to write a textbook at the end of the experiment on whether it was the right choice or not. We're definitely committed to that experiment at this point. And so there are tools that have been developed to help migrate Python 2 code to Python 3 code. Other than that, you're a part of the transition with all of us. That's pretty much what I can say. But it's worth knowing that the people who develop, the core Python developers, agonized over this question for a long time. Their goal was never to make anyone's life hard. It was sort of a very considered decision that a fork was the right path forward. So we'll see what history says. Yeah.
How long has the Python software foundation existed, and what are its primary revenue streams for continuing to exist? Basically rely on the generosity of people that use Python code and basically give something back?
Yeah, that's a good question. So the question was, how long has the PSF been around and how is it funded? The PSF has been around for a while. I can't quote a year to you, but for the majority of the time that Python has existed, because you need some entity that's going to be able to protect IP stuff, enforce trademarks. The PSF is primarily funded through three mechanisms. So one is that the PSF underwrites the PyCon North America, which is that largest annual Python conference. That conference is run as sort of an extension of the PSF as a sort of non-profit conference, but money from that, proceeds from that conference can get reinvested in the community. So they sort of, people pay to go to PyCon, and that money comes back to the PSF to be reinvested. Another source of money is companies who use and like Python and want to support the development. If your company loves Python and wants to support Python's development, there's a sponsor membership program, and you get the feel good of supporting Python, but you also get your name on the page and your quote in rotation on the website and things like that. And then the third thing is just individuals who want to support the language. So those are the three big things. Yeah.
What advice do you have for companies starting to make a transition to Python?
What advice do I have? You made a great choice. Congratulations. Python has a really robust ecosystem, so if you find yourself reinventing the wheel, as you might have had to do with other languages, maybe stop and double check that there aren't other people who have solved this problem for you before, because Python has an exceptionally robust sort of library ecosystem. I would encourage you to be a part of the global community. Come talk at PyCon, speak at user group events. In terms of sort of migrating to Python, I think you're going to find that it's a pretty pleasant experience for given the language choices that you might have had. In general, things that you write in Python are shorter, easier to write, easier to read, easier to document and maintain. There are some studies that actual academics conducted and wrote up that suggest that all this is true, that the white space enforced by Python really does produce more readable, more maintainable code. So I think you're in for a good time. Yeah?
So as one of the people who used to work in IT, technology industry, and has recently migrated to academia,
Yeah.
I'm painfully aware of a lot of what you had on your software carpentry slide.
Yeah.
And I wasn't sure, is that a general concept? Like if I wanted to promote those things at the university that I'm at now, and make sure that it sinks in and realize an effective change to people that should know about version control and all these concepts that we take for granted, is there a good way to kind of go about that? Recommend?
Yeah, so the question was, hot dog, I work in a university now, and that software carpentry thing sounds exactly like what all of my scientist friends need, because they don't know anything about software development. How can I hook them up? I think the best thing to do, honestly, is to get in touch with Software Carpentry, and they will come help you run an event at your university. I mean, in general, I think that we are sort of at an inflection point in the sciences where the tools are becoming easier to use. Git may be easy for us as developers to use. It's maybe not so intuitive for scientists, but a lot of layers focus on scientists, focusing on collaborating around scientific data are being built on top of these tools, and this is making the barriers to entry for scientists to use basic software engineering principles much lower. And I think these are a prerequisite to reproducible data and open access being the norm. But I think it's happening. It is steadily but surely happening, and so we're going to, in the next 10 years, I think we're going to see a total transformation of science into a semi-software engineering discipline, which is going to be amazing. And this is going to change the world. Yeah.
Can you share some experiences of migrating to point 2.x, 4.2.x, how people are able to do it,
I had a hard time hearing you, but was the question just what are the options for migrating from 2 to 3?
people's experiences migrating from 2.x to 3.x so far?
Yeah, so there's a Python wall of shame that will show you who has and hasn't migrated from 2 to 3, which if you Google for Python wall of shame, you'll find it. And people will take different tacks for migrating their projects from 2 to 3. Some people choose sort of single code base, support both model. Some people use tools like 2 to 3, which will sort of do this conversion for you, and it gives you a code base that now you can run on 3. The hardest part, how difficult it is to port your project from 2 to 3 tends to depend on the domain in which you're working. So for example, I'm a maintainer for Twisted, which is an asynchronous networking library written in Python. And Twisted deals with a lot of sort of getting data onto the wire, right? So, I mean, it's a lot of networking code. And as it happens, one of sort of the major interface changes between 2 and 3 was the way that you deal with bytes and strings and things like that. So for Twisted, because of the domain that we're working in, we have sort of an exceptional amount of work to do when it comes to the transition. For a lot of projects, the only thing that's really changed is that print is now a function. And the conversion is really easy. So it really depends on your specific domain. But there are a lot of tools that help you, and there are a lot of people have documented sort of case studies on their experiences. So there's a lot of literature online about the various options you have for doing this. So don't be afraid. If you are here because you're facing a 2 to 3 transition, there are lots of resources to support you. Any final questions? Anyone want to volunteer to use Python 4 already in the enterprise? Okay. Yes. Absolutely.
So, how do you decide to address those issues by integrating vendors and other partners, other big vendors in the industry to adopt and embrace Python and start building and contributing code towards Python?
Yeah, so it's a little bit hard to discuss that in the abstract because it sort of depends on what vendors you want to interact with. I think you'll find that because Python is, even though it's so much more than a glue language, given that it's such a nice, efficient language to use for scripty, gluey things like writing API bindings and writing little utilities. I think you'll find that a lot of vendors have already elected to support Python. And certainly the folks on those sort of slides in various domains have all clearly elected to use Python already. Of the language choices that you have, I think Python's in the top 5 for most domains. So I think you're in pretty good shape there. But again, I'd be happy to sort of talk offline, but it's hard to talk specifics. Cool. Yes.
Can you just go through sort of the list of language features that Python has, like is it dynamic or static, is it object-oriented or functional, like those kinds of things?
Yeah, absolutely. So Python is a dynamic language, so you don't declare types on things, and it's an interpreted language. You can run things interactively. Well, it's an interpreted language. You can run things interactively at the interpreter. There's not an explicit compilation step. It has a very lightweight syntax. It enforces white space, which is often something that it tends to be controversial initially for people who are learning Python, but they grow to love it. Yeah, so part of why Python is such a great teaching language is because while everything in Python is an object and object-orientedness is a natural way of expressing things in Python, you can sort of defer. You don't have to. It's not like in Java where like everything is everything's a class basically. So in Python you can deal with just functions. There are also many sort of functional programming tidbits in Python. It has lambda and map and filter and things like that. Yeah. The best way to learn Python, the best way is to spend an hour working on it. And a funny thing about Python, so I spend a lot of time teaching beginners Python as part of the Boston Python user group. And one of the amazing things about Python is that after like 3 or 4 hours of learning the language, you're able to write useful software. Like that is enough to learn the language primitives and a couple of useful libraries and write some useful scripts or interact with some useful APIs. And that, which is sort of amazing given that like high school students and university students may spend an entire semester getting up to that point in languages with higher syntactic overhead. Yeah.
New to Python, the white space is pretty good right now. So is there a good free IDE or whatever to get started?
Oh yeah, good question. So like, how do people develop in Python? Are there good IDEs? There are. Many people choose to not use an IDE. They use their favorite text editor. That's how I prefer to work on Python. There are absolutely Eclipse plugins. There are really nice IDEs that you can pay for. A really popular one is called PyCharm. In general, there's a pretty robust ecosystem around your development environment for Python as well. There are Vim plugins, yada yada. Yeah, PyCharm. 2 minutes, 2 questions? Either way, 2 seconds. Thank you. Any final questions? Thoughts, concerns? Python horror stories? Oh, thank you.